Our problem. The 100 kilogram box shown above is being pulled along the x-axis by a student. The box slides across a rough surface, and its position x varies with time t according to the equation x equals 0.5 t cubed plus 2t, where x is in meters and t is in seconds. Determine the speed of the box at time 0. Okay, well, velocity is the derivative of position or displacement. So since we know this is the displacement, we're going to take the derivative of it. So it'll be 1.5 t squared plus 2. And since it's time 0, you put it into t, and that cancels out. So you're left with your velocity at time 0 equals 2 meters per second. Well, now we have to determine the following functions as functions of time t. Okay, the kinetic energy of the box, and kinetic energy. The formula for kinetic energy is 1/2 mv squared. And what we have to do is you plug in your variables, like 1/2. The mass of the box is 100 kilograms. And the velocity of the box, as seen here, or in this equation, is 1.5 t squared plus 2. And we're going to square that whole function. So that's going to equal 50, because you have that, 2.25 t to the 4th plus 6 t squared plus 4. And you're going to distribute the 50 to each of these things and terms, and then you're going to get your final answer as 112.5 t to the 4th plus 300 t squared plus 200. Okay, to find the net force acting on the box, we're going to use our favorite equation, F equals ma. Yeah. And since we have the velocity, we know that acceleration is the derivative of velocity. So, going back to this buddy right here, sorry I crossed it out. If you're going to take the derivative of that, it's just going to be 3t. And you just put that back into the force equation, and you know the mass. So it's 100 kilograms times 3t. So the force equals 300t. And the power being delivered to the box is, we know that one of our power equations is force times velocity. So we found the force up here. We put that right in here. 300t times the velocity. And the velocity, back up there, 1.5 t squared plus 2. And you multiply the terms together, and it's 450 t to the cubed plus 600 t. And calculate the net work done on the box in the interval from t equals 0 seconds to t equals 2 seconds. Okay. So work is change in energy, or in this case, change in kinetic energy. So we just have to subtract the final kinetic energy from the initial one. So our beginning kinetic energy is,